Okay, Assalamualaikum and hello. So today we will continue with chapter 12, Polynomial. Okay, so let me check first whether I have already recorded or not. Okay, so the objective of the study here is to represent the polynomial as vector. So basically you just you know polynomial, but you change it into vector in the MATLAB. And then you can use the MATLAB to find the polynomial root. Okay, use the MATLAB function to multiply and divide. Okay, and also use polynomial to model a data through a curve fitting function of polynomial and polyval. Polyfit and polyval. Okay, so what is polynomial? So polynomial is a mathematical expression consists of sum of many terms. Okay, so basically this one. Okay, so if you recall, this is a linear equation, y equals to mx plus c. Okay, this is a linear equation. So you can see here, this is a polynomial with 1 degree. So if you recall, ax squared plus bx plus c equals to 0. So this is also polynomial with 2 level. This is a quadratic equation. This is linear equation. Okay, you also have x cubed plus x square plus x plus 1 equals to 0. So all of these are polynomial. So you can make this as high as possible and you don't need to include all. So for example, x power of 4 plus 1 equals to 0. This is also considered as polynomial. So, okay, I hope you understand this, what is polynomial. So the application, there are a lot of application. Okay, so in electrical engineering, polynomial can represent the system. Okay, and you can evaluate the stability of a system, and you can model something, and you can use to calibrate something. So basically you can use polynomial into a lot of things, especially in control. So maybe you are in the first year, so you don't know what is a control yet, but if not mistaken, you will learn this in year 2 and year 3. So you will use this if you have the knowledge on how to use polynomial in the MATLAB. It will help you greatly in your next learning. So vector representation. Okay, so polynomial coefficients are normally constant and can be grown into a single vector. So basically what it says that, so what it means that, for example, you have 3x square plus 2x minus 1 equals to 0. So you can represent this into a MATLAB vector. For example, here I call it this one is a. Okay, so a is equals to just 3, 2, 1. That's it. So you just take this value. Okay, so for example, if 3x cubed plus 1 equals to 0, you can change this into, for example, into MATLAB is 3. Okay, and then the power of 2 is 0, power of 1 is 0, and power of 0 is 1. Okay, so this one is basically 3x cubed plus 0x squared plus 0x plus 1 equals to 0. Okay, so that is meant by changing the polynomial into a vector. This is a MATLAB vector. Okay, so in MATLAB, coefficient vector can be either form of row or column. So this one you can be either column or row. So with the coefficient represent a vector, you can provide a function with polynomial. So of course, when you have a polynomial, you can do a multiplication, division, find the root. Okay, and you can evaluating and curve fitting. Okay, curve fitting, remember before, like I said, okay, polynomial. Okay, so you have interpolation which use all the point. Okay, so you have, for example, here, let me clear this up first. Okay, so if you recall back, you have interpolation and you have curve fitting. Okay, so in interpolation, for example, you have point like this. Okay, so it will try to run all the point. Okay, so it will meet all the point, but curve fitting is different. So curve fitting, for example, you have something like this. Okay, it will try to find a polynomial that can fit all the data. It doesn't mean that you have to run all over the data, but it will try to feed it with all the data. Okay, so that is the difference between interpolation and curve fitting. Okay, so in this chapter you will learn curve fitting also. Okay, so here are the example. So you can see here the example I showed you before. So you can see here, let me open this way. Okay, so make sure you know how to do this. Okay, how to change the polynomial into vector in MATLAB. Okay, so you can see here, this is order 4, so 3. So this is easy because you can see here 3, 4, 3, 2, 1 and 0. So you can just copy it directly. So 3, 2, and then this one is negative. Make sure you include the negative. Okay, I remind again, make sure you include the negative, and then the 1 and 0, x power of 0. This is x power of 0. Okay, so make sure you know how to convert it. And for this one is x power of 1. Okay, so remember, if you have x power of 1 means that you have at least 2 number. Okay, you look at the highest order and you change it. So this one is 1, negative 1 here. So this one is negative 6 and 3. And of course, remember, you have to include everything. So plus 0x, this is 0y, 0. Okay, so means that negative 6, 3 over 2 and 0. And if 8 is just 8, because 8 is just x power of 0. Okay, a power of 3 is, so you have a power of 2, 0, a power 2 plus 0, a power of 1 plus 0, a power of 0. So you have 1, 2, 3, 1, 2, 3, 3, 0. Okay, so this one, this one is, be careful. When you see this, you have to rearrange it according to the order. So you have to change this. This is negative 3, x power of 3, x power of 2 minus 2, x power of 1 plus 1 equals to 0. So you can see here negative 3, negative 2 and 1. Okay, so make sure you arrange again. So I repeat back, make sure you arrange according to the order. Okay, so this one, there is a lot of mistake before, so make sure, I repeat again, make sure you rearrange this. Okay, and this is another example. This is considered as a function. Of course, you have to rearrange everything. Okay, so it's to, okay, let me clear this first. Okay, so you can see here, so this is y, because this is the function of y. Okay, so you have to rearrange it first. 3y squared, okay, plus 2y, and then you can see here there are two terms that y equals to 0. Okay, 0 order. Okay, so plus a minus 1 in this form, y power of 0. So make sure when you do this, you convert, you rearrange it first. You can see here 3, 2, and then a minus 1. Okay, so this is another example. Okay, So you can see here, this is the function of y. Okay, so be careful. Okay, if you have multiple unknown here, okay, you have to look at the function. This is the function of y. So means that you have to look, you have to assume that x is a constant, y is the variable. So 3x, okay, because this is y3, and then y2, this is y3, and then plus 0y2, because there is no y2 here, just put 0y2, and then plus xy plus 1. So you can copy it back, 3 0 3 0, and then x and 1, 3 0 x and 1. You can just use a space here. Okay, so this is considered as row vector. So you can use also column, but it's not common. Just use a row, easier. Just use spacebar. Okay, same here. You can see here, this is the function of x. Okay, so when it comes to function of x, okay, so you can group the x first. Okay, you can see here there are 2x here. So just make it x, and then 3y cubed plus y. Okay, x, and then there is no more x, so just plus 1, x power of 0. So 3y squared plus y plus 1. Okay, so make sure you know how to do this. And then this one, for this function, for this case, you have to expand. Okay, so you can see here ax squared plus ax plus x minus 3. Okay, so ax squared plus a plus 1 x, okay, minus 3x power of 0. Okay, so you can copy it back. So a plus 1 and negative 3. So make sure you know this skill, how to convert polynomial into a vector in MATLAB. So we continue with the next function in MATLAB, which is called conv and deconv. So if you recall here, conv is basically multiplication, and deconv is division. So for division, you can see here, for multiplication, you can just get the direct answer. But for deconv, you have a remainder. Okay, remainder. Okay, so you have a remainder. So I will show you how to write this, okay, remainder later. So what is remainder? Okay, so basically, if you recall how to do it manual, okay, for example, I give you 7, okay, 7, let me change to, okay, I change to whiteboard first. Okay, so if you recall remainder, what is remainder is, so for example is 7, okay, 7 divided by 3, for example. So 7 divided by 3 is 2, 2, 3 and 6. Okay, so the technical issue here. 2 multiplied by 3 is 6. You have a remainder is 1. Okay, so when you want to write this is just 2 plus 1 over 3. Okay, still hang. Okay, so 1 is just from here, the remainder, and 3 is just the divider. Okay, that's it. That is mean by this sentence. Okay, so no need to worry, I will show you later. Okay, so this is an example of conv and deconv, multiplication and division. So we look at example 12 and 2. So this is a function and this is a x function. Okay, so you have this and you have this. So you can copy here. This is A, this is B. So this is A, okay, and this is B. Make sure you know how to convert this. Okay, and So if you want to do the multiplication, you can see here, you don't need to do this manually, of course. You can just use the Conv. Okay, Conv, and you can see here A and B. Okay, you have a multiplication of both, and you will get the answer. And one more thing I forget to mention, make sure this is the numerator, this is the denominator. You divide by V. Okay. For this one, no need to worry because you will still get the answer if you flip this. But for this one, it will be different. Okay, make sure you know that. Okay, so you can see here you get the answer, and of course you have to convert this back into a equation here. So 1, 2, 3, 4, 5, 6. So 6 means that the x power of 5 is the highest. Okay, if you have 6 number, it should be 6 minus 1. Okay, 1, 2, 3, 4, 5, 6. So this is x power of 5. This is x power of 4. This is x power of 3. This is x power of 2. This is x power of 1 and x power of 0. Okay, and how about Deconv? Okay, so this one you can see here, this is the same thing, A, and this is B, but this time it is division. So you use Deconv. Okay, and make sure the numerator, the upper side is A, and the denominator is the lower side, which is this one, is B. Okay, and of course you need to show as this one. Okay, so you have to show the result and as well as the remainder. Okay, so you can see here G is 1, 3, and remainder is this one. So how to write this in this form? Okay, the polynomial form. So you can see here this is 2 label, so means that this is x power of 1, this is x power of 0. So x plus 3. Okay, how about remainder? So you can see here remainder, of course, 1, 2, 3, 4. So this is x power of 3 because it has 4, right? So 4 minus 1 is 3, x power of 2, x power of 1, x power of 0. Okay, so you just copy this. Okay, so just put plus. Okay, so this one 0, 0, no need to write. Okay, so 5x plus 17. Okay, and then you look at the remainder again, the divider. Okay, the numerator. So you just divide by x squared minus 5. So that's how you write it back. Okay, so this is the G. Okay, this is G, and this is the R, remainder. Okay, you can use other form of this. Okay, you can use CD, for example, CD. Okay, either way you can write anything, but this is the remainder. So this is the R, and this is just a divider. So this one, okay, the B. Okay, this is the B. This one, you just copy it back. This is how you convert from the vector to the polynomial. Okay, so you can see here the result. Okay, so I hope you can understand how to do conversion and not conversion, multiplication and division for the polynomial. Okay, before we proceed, take a 5-minute break and make sure you slide in your attendance here. Okay, this one I have a small setting error. Okay, but I think you can still use it. Okay, slide in your attendance, and we have a break of 5 minutes. Okay, so we continue with the system representation. So polynomial is quite useful, especially in many engineering. Okay, so you can represent anything into a system. So you can look at the assignment I give you. So basically, your power converter, for example. Okay, so let me show you. So you charge your phone, right? So this is your phone charger, and this is the output. Okay, 5 volt, for example. Okay, so this is the input is 240 volt. Okay, so this is one type of charger. Okay, So this one can represent it as a function. Okay, so for example here 1 over LC, okay, divided by S squared plus S plus I think 1 S over RC, I think 1 over LC. So this one is V in divide V out, I think V out divided by D, okay, if not mistaken. So this is one of the characteristic. Okay, so this converter you use to charge the phone can represent it as this equation. So this is not accurate actually. There are a lot more complicated actually. So basically the converter is something like this. You can represent something in this form, okay, in the form of polynomial. This is considered as polynomial. So this is 2 level, but the lower side is 2 order, okay, and the upper side is only 0 order. So this is what it means by polynomial to represent a system. Okay, and of course you will learn this in your year 2 or year 3 in control, and represent in Laplace domain. Okay, you use S, so you can see here S. Before this you use X, right? So many of things you use X. Okay, this one is usually for normal polynomial, but for Laplace domain, okay, you use S. Okay, S to represent the system. Why is S? Okay, so before I continue, I just want to show a little bit about control. Okay, because it's easier for you to understand after this. Okay, I just want to show you some simple introduction, okay, on control. For example, okay, I think you already learned about the RC circuit, right? RLC or something. Okay, the second order I think is called. Okay, I think you already learned about this. So if you recall here, you will have a response here. Okay, something like this. Okay, so this is in time domain. Okay, time, and this is the response, the amplitude. Okay, it shows something like this. This can be either voltage or current. Okay, so you will I think you are currently learning about this. This is a second order circuit, I think it's called. Okay, so basically this is in time domain, or you call it T domain. Okay, but in time domain we cannot see too much of anything. Okay, you can only see this one. Okay, you cannot see the stability and everything. It's hard to analyze. So to analyze this, you change the time domain here into a frequency domain. So instead of using time, okay, you use 1 over t. Okay, frequency domain. So F domain, okay, or you also known is as S domain. Okay, that's why we use S, okay, because to represent the frequency domain, and S is equals to JW. Okay, no need to worry, you will learn this later. Okay, I just want to introduce you to this. So in frequency domain, this amplitude will change into something like this. Okay, this is usually the board plot. This is usually linear time. Okay, this one is usually board plot. This is 1 kilohertz, something like that. 10 kilohertz. This is 100 kilohertz. So no need to worry. I just want to show you that this is the time domain. This will become the frequency domain. Okay, so that is just some introduction on the Laplace domain. Okay, why you have to know this? Because you have to do this. This topic will highly related to this. Okay, so you can see here, this is the system function, example 12.3. Okay, you don't need to understand it too much, but you need to know how to convert this into a MATLAB and create a function, system function. Okay, so you can see here, figure show the system of PID controller. This is one type of a controller here. You can see here, the controller used to stabilize the plant. So this is the system. Okay, the system usually called a plant. Okay, so you can either here can be a car, okay, a car or charger. Okay, so this is the controller. make sure that the car doesn't go wild. Maybe this is a nuclear power plant, so this controller prevent from the nuclear plant from meltdown. So this is somewhere is a general control system. So this is the reference input, this is the controller, and this is the actual output. This is basically you need to know just a little bit. This is the feedback loop. Compare feedback loop with the controller. You give the error, okay. Of course, this is the desired output, this is the real output. You minus it, you get the error, okay, the difference between the desired and the output, okay, the real output. Go into the controller. Controller will produce the respected output to the plant. Okay, this is basically just a simple system, real control system. Okay, then you can see here the G. Okay, this is the G. This is the controller. Okay, this is a PID controller. Okay, PID. Okay, PID divided by S. So this is don't need to memorize this. This will be given. Okay, and this is the close. I think this is the closed loop. Yeah, this is the closed loop equation. You can see here. This is the closed loop equation. So you can see this is a you can see here. This is a S domain or frequency domain. Okay, this is the function here. Okay, it is a polynomial, and you have to. You can see here G and hash multiplication. G and hash is also multiplication. Okay, G and hash is also multiplication. But be careful, you can see here N and N. Numerator is the upper side. Okay, D is the denominator, is the lower side. So no need to memorize this, but you have to know how to multiply, divide, and add. Okay, I will show you this later. So you can see here, now we will have this example. So this is PID. So P for I is equals to 1, D is equals to 2. Okay. So Gn numerator. So you can see here, dpi. So that's why it's called dpi at the upper side only. Okay, the upper side. Okay, and the denominator at the lower side, you can see here, this is S. So 1 and 0. Okay, so I hope you know why. Okay, because this is just plus 0 as power of 0. Okay, and the transfer function for the hash, the plant, this is the plant. Okay, remember, so the plant is this one. This is the plant. So of course you separate the numerator and denominator here. Okay, I think you already know how to write this, and then you use this formula. So Qn is equals to Gn hash n. Okay, you can see here, this is Qn, this is this one, and this one is the same. This is Qn. Okay, so Qn is equals to Conv Gn hash n. So you just multiply this one. Okay, conv. Okay, and then you can see here Gd hash d. Okay, so Gd hash d, this one, Gd hash d, because of the formula here, Gd hash d. Okay, Gd and hash d, you multiply it. G denominator, hash denominator, you multiply it. Okay, and then you use add poly. So you recall back this one. Okay, sorry, I don't have this. So okay, basically to add polynomial, you just use this code, add poly. Okay, so you can see here the denominator Qd is just add this one with this one. So after this you get the Qn and Qd, this one, Qn and Qd. Okay, I hope you understand how to represent a system, okay, by using add poly, conv, and okay, deconv maybe later. Okay, so this is how you represent the system. Okay, so we have complete how to represent a system. Now we move on to Polyval. Okay, so Polyval is actually polynomial evaluation. So what is Polyval? Okay, how I can explain this? So basically, Polyval, you have a polynomial here and you evaluate each point. Okay, so I give you example here to easy for you understand. Okay, so what is Polyval make that is that, for example here, y equals to 3x plus 1, for example. So Polyval is basically try to find the value of y when x is varies. Okay, so for example, x is equals to, this is y. Okay, so 0, 1, 2, 3, 4. Okay, so basically you evaluate the value of x. So 0 is 1, 1 is 4, 2 is 6, 7, 3 is 9, 10, and 4, 13. Okay, so this is the function of Polyval, just to evaluate this. So if you recall back the formula here, y is Polyval px. Okay, so y is equals to Polyval px. Okay, so x for this case is from 0, okay, sorry, this one, 0 until 4 with the step of 1, and p here is this function, so 3 and 1. Okay, that is how you use Polyval. So I give you example here. Okay, you can see here, find fx equals to 3x squared plus 4x squared 4x cubed, 4x squared minus 2x plus 1, for x equals to 3.5. So it can be either, x can be either vector or just a scalar. Okay, either way depend on you. So you can see here, you change this into a vector. Okay, this is a vector, and then put the vector here and then put the value x. It will evaluate the value, so you will get the answer. Okay, here are the frequency response. Remember the system here. Okay, and recall back, I show you the plot from time domain to frequency domain. So basically you have to evaluate the S domain. Okay, so how to evaluate the S domain? Same here. Okay, only you have to combine your Polyval knowledge with the system function knowledge. Okay, so let's have a look. Okay, so this one is continuity of this one, the system. Okay, example 12.3. Okay, so where the numerator and denominator you already calculate is Qn and Qd, so you just use Dval. Okay, so you can see here Qn, you already get the answer here, Qn and Qd. Okay, so you just write it back, and then this one is the frequency you want to evaluate from 0 until 10 kilohertz. Okay, make sure you know what is the function of E3. Okay, E is the power of 3. Okay, so E3 means that kilo, E6 is the mega, E-3 means that milli. Okay, make sure you know how to use this. Okay, this one will be in your final exam. Okay, so E power of 3 milli, E power of 6, -6, sorry, -6 is micro. Okay, and of course you have to, from frequency you have to change to S domain. Okay, this one no worry, it will be given, but just in case you need to know what is S. S is JW, S is JWF. Okay, but it's okay, it will be given, so you can see here S is equals to J 2 pi F. Okay, so JW, S is equal to JW. Okay, W is 2 pi F. Okay, and Q and S Polyval. Okay, so of course you have to evaluate the Qn. Okay, you can see here, this is the Qn numerator and denominator with the S. Okay, evaluate the S, and then you just divide the value. Okay, the numerator and denominator. So for this case, you don't need to divide it, Deconv. Okay, for this case, you don't need to do the Deconv, but you can do also Deconv Okay, Deconv, divide it first, and then you just polyval the combination of it. Okay, that is one way to go. Okay, but this one is another way to go. Okay, so maybe I will show you. If I just talk, maybe some of you still don't understand. Okay, this is, you do it separate. Okay, numerator and denominator. You can combine it. Q is equals to Deconv Q and QD. Okay, unfortunately, after this you have remainder, right? Remainder. So remainder, you cannot do this. So basically, like it or not, you cannot do this. You have to do it like this. Okay, you have to use the numerator and then denominator, and then you divide it after that. Okay, sorry about that, because I usually combine it and use it in a separate coding. Okay, so there are other types of coding, but it is not in our syllabus. Okay, so no need to worry for that. And then figure, and this one, recall back semi-log x. Okay, you plot the f frequency and then plot the absolute qs. Okay, because this is the, you can see here, this is I. Okay, I is the complex number, you have to use absolute. Okay, and make sure you put 1. I think if you just put I, it will not work. Okay, and you have to plot the semi-log. Recall back chapter 6. Of course, this is just a label. That is how you represent a system in the form of frequency domain response. So the plot will be something like this. Okay, okay, you can try it on your own. Okay, take a break for 5 minutes and we will continue with the roots. Okay, I think most of you already know what is root. Okay, but I will show you later. Okay, so after 5-minute break, we continue. So if you recall here, for example, this is x squared plus 3x plus 3, for example, equals to 0. So means that this is example, I don't know the plot is actually. So it should be this way, right? So what is root is actually what is x when equals to 0. So this one. This is the root. Okay, because this is second order, means that you have two roots. Okay, 2, 1, or complex root. So recall back your quadratic. Okay, if you can use your calculator, remember you can solve the x. What is the x when equals to 0? That is how you find the root. So if you use a MATLAB, you can just use roots, R-O-O-T, and don't forget the s. Okay, and the polynomial. Okay, so you can see here, this is the third order, x cos power of 3 and x power of 2, 1, 0. So just write it. Okay, and then write the roots, the polynomial. So you will get the root. Okay, that is how you solve the polynomial. Okay, here I give you some example on how to use roots. Okay, you have a large object vertically and how long it takes to hit it back. Okay, so no need to know too much about this, but usually you can have to look at the equation. You can see here, d is equal to vt plus g divided by 2t squared. This one is, I think t is the polynomial. Okay, so and v and g, you can see here, this is a constant. Okay, it already given. Okay, so you have to write the polynomial in the MATLAB vector. So you can see here, this is the highest order. Start with this, and then 30, and then 0. Don't forget, if you have t is the highest one, you have to put the t minus t equals to 0, t power of 0, and then you find the roots. Okay, because of course ground is equals to 0. Okay, so you have the roots, means that you get t ground is this one. So this is basically you want to set the r is not 0. Okay, I will show you later after this, but you have to know this is the root. You get the root at 0, the distance at 0 and distance at 6.122, this one. Okay, at time 6.1 second, the object fall to the ground. Okay, according to the equation. And then you have the Polyval weight, okay, from 0 and the step is 0.01 until the T ground. Okay, so this one is just basically remove the 0. Okay, so T ground is basically just remove the 0 because you want to use it as Polyval. Okay, this is a vector of Polyval. You want to evaluate this and then plot it. So this is the result. So you can see here at the time, this one it will increase until at a certain point it will drop back. Okay, so that is one application for the Polyval and the roots. Okay, combination of that. Okay, now we'll look at another example on what is the usage of roots. Okay, so basically you can use root as to determine the system stability. So example 12.8. So you can see here relate to example 12.3. Okay, stability of the system can be represented as polynomial, as mentioned before, and checked by the root of the value. Okay, so if a system is stable if all the denominator at the lower side, the roots are less than 0. Okay, so if your system has larger than 0 at the denominator, okay, how do I show you? Wait, okay, so how to evaluate the system stability using polynomial? So you can see here Q S is Q numerator S and Q denominator S. Okay, so you only look at denominator, you don't look at the top side, you only look at the denominator. Okay, as long as the QD, okay, root of QD, okay, is less than 0, system stable. Okay, this one we will learn in control in chapter in your year 2 or 3. Okay, so basically something like this. Okay, your roots will be stable. This is stable because it is negative. Okay, negative side, the S. Okay, and if this one, the root is here as not stable. Okay, so make sure you know this. This is just a simple theory. Okay, if positive, it's not stable. Okay. Okay, so now create a MATLAB function that check the stability of PID control system described in this. Okay, so of course you can see here the G1, G2, G3. Okay, so this is a function to check the stability, and the C is the controller PID value. Okay, Pn, okay, P is the plant numerator, plant denominator. So basically you just use back the knowledge you have learned before. So G is the C1C. This is the control. You can remember back this one. Okay, this one. Okay, this is just a control here. Okay, and this one is 1, 0. Of course, the control again. Recall back the previous example. This one is at poly. Recall back how to multiply it. This is you already learned before. So basically, you do all this and you look at the root. Okay, this is the root. Okay, remember I show you. This is the root of the system. Okay, and then you find the root of the system here. Okay. Okay, this one is length is basically determine how much root you have. Okay, and then f print ref root percentage. This one is the f print f, the chapter 2. Okay, and this one is 1 until the length of the root. Okay, this is the real of the root. Okay, remember the root can be complex number, so you have to use the real and image root. Okay, so basically it's just separating the real number and imaginary number. So what is the function of the, I think this one is not in our syllabus, right? But so let's have a pen. So 3 plus, for example, ROOT equals to 3 plus J4. So basically real ROOT equals to 3, and IMAG ROOT will equals to 4. Okay, so it's just to separate it. And then if you can see here, R equals to root more than 0. Okay, basically remember, if you have root is more than 0, the system will not stable. So is empty is basically check whether R is empty or not. If all the root is less than 0, okay, if all the root is less than 0 means that this one R will be empty. But it's more than 0, okay, so the system is stable, and this one is not stable. Is empty is basically checking the R value whether it has value or not. Okay, so you can check the system here. So root 1, root 2, okay, system is stable, you can check it. Okay, so this is not stable. You can see here the real number is positive. Okay, this one is positive. Okay, that's why the system is not stable. So that is how you determine the system stability. Okay, okay, make sure you know how to do this. Okay, try to understand this. Okay, and we will continue polyfit in our next class. Okay, that's it from today. So thank you, and don't forget to slide in your attendance.